Hi, welcome to the independent learning module on edema formation. My name is Paul Stanley, and this is the CPR block 2013 at the University of Arizona College of Medicine, Phoenix. The learning objectives for today include those on the following page. Give a good definition of edema, describe the various anatomical areas subject to edema, compare and contrast cases of edema brought on by changes in the following Starling forces: hydraulic conductance of the capillaries, capillary hydrostatic pressure, capillary oncotic pressure, and lymphatic insufficiency. Finally, you should be able to list various treatment modalities for edema and how each impacts the Starling forces noted above. So by definition, edema really is a physiological situation in which the volume of the interstitial fluid due to filtration out of the capillaries exceeds the ability of the lymphatics to return that fluid to the circulation. So in order to fully appreciate fluid movement, we have to be reminded of where body fluids are located and how they are maintained. So the balance of body water is very closely regulated by many homeostatic mechanisms, including those associated with the kidneys, the endocrinological pathways, and the cardiovascular reflexes. All of these and others attempt to preserve cardiovascular volume and therefore blood pressure. So in the case shown here on the right, total body water in any given day may include about 2.5 milliliters, 2,500 milliliters of fluid in. That may come from about 1,200 milliliters of fluid from drinking water and soda and other beverages, about 1,000 mils or 1 liter from food, because many food types are composed primarily of water, and of course we make metabolic water through biochemical pathways. And that accounts for in most individuals around 300 milliliters of fluid production. So a total of 2,500 milliliters of fluid into the system. So how does the water get out of the system or out of the body? Well, it includes insensible water loss, which is basically the water vapor that one loses during expiration of the lungs. About 100 mils per day is lost as sweat. Now, of course, this varies greatly depending on the ambient temperature, the ambient humidity, exercise level, etc. Perhaps 200 or so milliliters lost in feces, and a lion's share here, or the largest contributor anyway, of 1,500 milliliters in the urine. So if you add these up, this is a total of 2,500 milliliters total loss from the system. So in this pretend scenario, 2,500 milliliters of total water into the system, 2,500 milliliters of water total out of the system. This individual would necessarily be referred to as being in water balance, because water in and water out are identical. All right, so here's some considerations to think about regarding total body water. So for most of us on average, water constitutes about 50 to 70% of our body weight. And in fact, as our body fat content increases, that necessarily yields a lower body water percentage. And the reason for that is because water is very poorly stored in fat spaces. Because of this, and knowing that females in general, on average, have a higher body fat than males, the total water percent in females is typically lower for that reason than in males. Now, total body water also decreases with age due to the fact that most of us put on more body fat as we age. So here are some examples over here to give you an idea of these benchmarks. So as we go from younger ages to older ages, both in males and in females, total body water tends to decrease. And that's mainly because of the increase in total body fat. Also, for any age group, we typically see that females, on average, have a lower body water percent than males, again for the same reason, increased body fat.